Welcome to Physical Science. Yay. Starring Rika. You're awesome. Okay. Yesterday we looked over these limiting reactant problems and stuff like this, and there's a lot to it. I'll just go over, it depends what you're starting with. If you have grams or liters of something, you've got to convert both things to moles, both reactants or reagents. And then you got to just choose one and say, if all of the moles of this chemical reacted, how many of the other would you need? Based on that, make a decision. Which one is going to run out? That's the limiting reactant. The other one's called the excess. You've got extra. And you can use that limiting reactant to do calculations of how much product will be. This is where we went through examples. This is where we left off. Percent yield. Yield meaning the amount that produced a product. Okay. Theoretical yield is the maximum amount of product that could be formed from the given amounts of reactants. Actual yield is the amount of product that actually forms when the reaction is carried out in the lab. Percent yield is the ratio of the two, times 100 to make it a percent. Now, so in theory, if I add, like we'll see this, but if you add two chemicals together, you assume that it goes 100%. So if you expected 100 moles to be produced, that's the theoretical yield. In actuality, though, reactions just don't happen 100% efficient and stuff, right? And you even hear about efficiency of high efficiency furnaces. It has the name right in it, right? And you probably haven't bought a furnace yourself, but maybe your parents have. And you might have an efficiency rating of 90%. That means, in theory, 100% of the energy should come out of this, but you only get 90 of that, right? Like, that's a pretty good efficiency. Okay. And I think we understand percents enough, but I won't go through this until we just go through by example, okay? So let's just go with the example right now. And welcome aboard. Have a seat and dig this up. Okay, I'm going to repeat myself. I wasn't recording when I should have been, so I'm going to just zip back and talk through these examples here. I don't know what was recorded. We talked about percent yields. You can pause the video and read these if you need. We did this example. Calcium carbonate. We found the theoretical yield using the grams of calcium carbonate. Theoretical yield of calcium oxide as asked. The percent yield was using then the theoretical amount on the bottom. The numerator was the actual yield, 13.1. We just did this example here, 50 grams silicon dioxide, figured out the theoretical yield, got the percent yield again. We'll go through one last example right now. If 15 grams of nitrogen react with 15 grams of hydrogen. Now here's one that does a little bit of everything. 10.5 grams of ammonia is produced. That's an actual yield. What's the percent yield of this reaction? So this one we have to figure out the limiting reactant. So we start with converting both items to moles. So 15 grams of nitrogen. You know what? Before we even start this, I'm going to just do the reaction. Okay, because we don't have one. So we've got nitrogen, hydrogen, maybe an ammonia. We've got to balance this. And I know I need an even number because both nitrogen and hydrogen comes in groups of 2, so I'm going to put a 2 in front of an H3. That takes care of the nitrogen, 2 ends, 2 ends. Now we've got 2 times 3 hydrogen on the right-hand side of the products. So 3 times 2 on this side. Now it's balanced. Now I can convert to moles. 15 grams of nitrogen. That's the chemical. And nitrogen on the periodic table is 1401, so N2 is 28. Toss that into a calculator. 15 divided by 28, 0.535. All right. Now, the moles of hydrogen. Hydrogen's got a very low mass, molar mass, 1.01 times 2, 2.02. Nine moles, 15 divided by 2.02, 7.42. I don't think you have to actually do any calculations here to figure out which one's in excess. Because by the mole, you can actually compare. And it's funny that again, there's way more hydrogen moles. Right? But let's just do a theoretical. Just to determine better. So, yeah, all of which one do you want to do? The moles of nitrogen or the, oh gosh, I wrote this down wrong. The moles of hydrogen. Which one do we want to use for this? Hydrogen or nitrogen? I don't care which one. Which one? Just choose one. Nitrogen. Nitrogen. If all of the nitrogen react, just choose one. And I'm going to say if all of the nitrogen reacted, now let's start with that. 0.535 mole. We would need according to the reaction, 1 nitrogen, 3 hydrogen, multiply 1.605 to 1.61. Hydrogen need. We have that. We have more than 7. This is X. The nitrogen is limited. We're going to use the limiting reactant, limiting reagent, either word, to do our calculation of the theoretical use. So we'll figure this out. We have 0.535 moles of nitrogen. Balanced reaction, we know that nitrogen is a 1-to-2 ratio with a mole. At this point, we would have moles of ammonia. 1 grams of ammonia. 14.01 plus 3.03 for the hydrogen. 17. Put this in and figure it out. 1, 5 times 2 times 17. 18 points. that's the theoretical yield. Now we can do the percentage. Wait for a second. Did you read it? 10.5 grams or more. You get 57.6 knots and 57.6. All right. The problems from the other day, now you can do all of them. You're going to. I'll expect you to have them done within class. This class. You got the time. Yeah, this period. Me?
Yeah. So my other business.